To find out the intersection of two straight lines, what we need to do first is, I want to actually draw this so you guys can see what I mean. So let's do a quick graph, and this is a really rough drawing. Okay, it might not be accurate in terms of the graphing that I'm doing. So let's say you have a line, and let me use a different color for that. A line that's coming this way, and then you have another line that's coming this way. Let me change the color of that. Let's go with green. So you have another line that's, oops, stuffed up there. And you have another line that's coming this way. Obviously, where is the intersection point in this graph is going to be where the red dot is. So that's where the two lines are intersecting. And we need to find the coordinates of this. So that could be A and B. I'm going to put in this case the coordinates of these two lines where they meet. Okay. So that's what we're actually doing. We're finding the intersection of two straight lines where they meet, and that we're going to represent this in terms of coordinates. Okay. So let's do an example. So if you are given two lines, an equation of two lines, let's say, y is equal to 2x plus 1, and y is equal to 4x minus 3. Now, if you did draw this on a graph, you can probably see where the intersection point is. And if you did like a good graph and it's an accurate graph, you can actually see it on the graph where it is. But in terms of working this out mathematically, what we need to do is we need to make these two equations equal to each other. So we've got equation 1 and equation 2. Okay. So first step 1, make two equations equal to each other. Okay, so what that means is we get the equation, so we get 2x plus 1 is equal to 4x minus 3. So we make them equal to each other. And obviously you can see that to find the x coordinate, or for x variable, we need to have x's on one side and the numbers on one side. And we did do questions like this before, but now we're going to use this same skill that we learned in terms of finding the intersection point of the x-axis. So when we find the x, we're finding the coordinate of x-axis. So let's actually put the x's on one side and the numbers on one side. All right. So if I move 2x on this side and move the 3 on this side, what happens? So the negative 3 becomes a plus 3, plus 1 is equal to 4x minus 2x, because that 2x is a positive, and when we move it to the other side, it becomes a negative 2x, and now we solve for x. So 3 plus 1 is 4, is equal to 4x minus 2x is 2x. Now we got 4 is equal to 2x. We divide both sides by 2, and then we get our x value, which is 2. So that's one of our coordinates, which is our x coordinate, x-axis coordinate. And if to find our step 2, and I'm going to put that here, step 2 is substitute, so sub x equals to 2 into any of the equations. So let's go in this case into equation 1. Okay. Into equation 1. And let's go y is equal to 2 times x. We know what x is. So I'm going to put that in bracket. 2 plus 1. So that's going to be 2 times 2 is 4 plus 1 is 5. So our coordinate or intersection point is going to be 2 and 5 for these two for these two equations when they intersect. Okay. So that's what we're finding. We're finding the coordinates of the intersection point where it's intersecting. Okay. So guys, as you can see, I have drawn a graph here, and in the graph you can see the intersection point. The intersection point in this graph is going to be 2 and 3 as a coordinate. And if you get a question like this, if it says, you know, what's the intersection point, and from the graph you can spot that out straight away. But we probably have to do some workings out. We have to do workings out to see if this is correct, and you know, and we can show manually or physically how to solve it. Okay, just in case if we're not given those intersection points. So our first step was step 1: make the two equations equal to each other. All right. So as you can see on the blue equation, we don't have a y equals, we have x plus y is equal to 5. But we can rearrange this equation to y equals to an equation. So the only thing we have to do is move that x to the other side. So I can rewrite this equation as y is equal to 5 minus x. Okay. So I'm rearranging to in the form of y is equal to. So now I can make these two equations equal to each other. So I got 2x minus 1 is equal to 5x, 5 minus x. Okay, so I can get the x's on one side and the numbers on one side. Let's move this x and let's move that -1 to this side. Okay, so that's going to be 2x plus x is equal to 5 plus 1. All right, that would be 3x is equal to 6 divided by 3 divided by 3, x is equal to 2. Okay, so that's one of our coordinates. And then step 2, okay, we sub x is equal to 2 into any of the equations. So let's number these. So that's equation 1 and that's equation 2. So let's sub it into equation 2. Okay. All right. So that would be y is equal to 5 minus x, which is 2, and that would be 3. So y is equal to 3. And you can see that our coordinates are 2 and 3. And that's what the graph has actually shown us as well. So that means our calculation is correct. Okay.